Hello, ladies and gentlemen. Welcome to Math 20-3, Chapter 4, Section 1, Scale Drawings and Models, Part 1. Now, today, we're looking at scale drawings and models, obviously. Look at the examples here. Real horse is 1,500 millimeters high, or 150 centimeters, or 1.5 meters, while the scale drawing of the horse is only 150 millimeters high. Okay? Now, your objectives today: describe contexts in which a scale representation is used, and determine using proportional reasoning the dimensions of an object from a given scale drawing or model. So, how does something go from this? When you look on the left here, you see the model. I believe that's a Hogwarts castle from the Harry Potter series. To this, on the right, you can see the Universal Studios Harry Potter attraction. And you look down here, these are people. Here's a person here. There we go. That's the person there. And I just served the person down here in the model, or in the real world on the right. So yes. How does something go from a model to real scale, real life? Now, in order to make something larger or smaller by a certain amount, while keeping the shape the same, we use a scale. Scales are used in many industries and careers. Now, what are some careers or jobs that might use scales? Scales are used in many industries and careers. What are some careers or jobs that might use scale models or drawings? Why would you use a drawing or a model? Well, carpenter, engineer. You're building a house, you don't have the diagrams full size, you make it to scale. Carpenter, engineer, mechanic. Lots of people. You might use scale drawings or models. Now, why is it important to these careers that they use scales? All right. Well, correct measurement. You really do want the correct measurement. If the engineer building the airplane you're flying in, good enough or close enough is not good enough or close enough. Okay? Now, before we go on, a quick review of ratio and proportion. Now, there's a worksheet to go with this. We'll do it after, but right now, I need you to do these questions. Can you solve 12 over 7 equals x over 2? What the heck, sorry? Here it is. How do you solve that? Well, the easy way, when it's something equals something, like this, fractions, cross multiply. So it's 12 times 2 equals 7 times x. 12 times 2, 24, equals 7x. Now, that's what I want you to do. And then I want you to get x all by itself. So cross multiply, and in this instance, it's 7 times x. So how do you get rid of times 7? Yes, divide both sides by 7. So x equals 24 over 7. If you grab a calculator, 24 divided by 7 is come on, there we go. 24 divided by 7 is 3.4. Now, I would rather you leave it as a fraction, but some people go, Mr. Sutton, we can write it as a decimal. I'm not arguing. You just leave it as a fraction, please. 3.4 is not good enough for me. Don't do it this way. Please leave it as a fraction. Now, I want you guys to do these two. Actually, I'll start this black one missing, and you guys do the purple ones on your own. Alright? So, starting this off, what do? Cross multiply. Alright? So it's 5 times x equals 8 times 3. Oh, wait a minute. That's it. You guys finish this. 8 times 3 is what? Keep going. Okay. So, this one's kind of messy. That's 8 times 3, right? 8 times 3, which is 24. So 5x equals 24. It's 5 times x. So how do you get rid of times 5? You divide both sides by 5. So you get x equals 24 over 5. Now somebody's going to grab the calculator and go, Mr. Sutton, that's 4.8. Don't do that. It is a fraction. Please. Anyway, so I see how this goes. Now it goes the exact same way with decimals. So observe this part 1 down here. 1.2 over 1.7 equals 5 over x. Cross multiply. And keep on going. I'm going to pause the recording. You do it, come back, and we'll compare answers. Okay? Okay. I'll come back. So I cross multiplied, and I got 1.2 equals 5 times 1.7. And 1.2x equals 8.5. I divided both sides by 1.2. Now, right here, you can read this as a fraction, but this is where I'm going, okay, you can turn it into a decimal. We'll call it 7.1. All right? I'd rather you left it as 8.5 or 12, but whatever. I'm not that big. Okay? So that's what I need you to be able to do with ratio and proportion. Now, here's a worksheet to go with this. So, I'm going to pause the recording here, and I want you to dig out this worksheet, the ratio and proportion one. Looks like this. Ratio and proportion review. I need you to practice some of these. So do these, and check your answers online. If you got any questions, shoot me an email. Otherwise, congratulations. This is the hard part of the class. But I need you to practice these, make certain you understand them. And yes, you're going to be handling this. Right, so check the answers on the answer key, and actually no, I'm feeling generous. We'll do one word, quick word question here. The back page shows the ratio of Mrs. Henry's age to Mr. Kerr's age is 3 to 4. Mrs. Henry is 25, how old is Mr. Kerr? Now, here, 3 to 4, this is the old-fashioned way of writing 3 to 4. I write it as a fraction here. I'm writing it 3 to 4, 3 colon 4, just to confuse you. So, this is Mrs. Henry. This is Mr. Kerr. So, Miss Henry is 25. Mr. Kerr is X. Now, I want to point out, once you get the equation, it's easy. Just want you, yes, we will be doing more of these word questions in the second half, but I just want to make certain you can, when you get to them, you can do them. So, how would you solve this? Yes. Let's multiply. 3x equals 4 times 5. 3x equals 100. And you get rid of times 3. Divide by 3. So grab your calculator, and that will be 33 1/3. Or you can leave it as 100. I prefer to go to 100 over 3, but whatever. 33.3. So Mr. Kerr is 33 years old. Okay? So that's ratio and proportion. So do these questions. Once you get them done, go back and watch the next video, and we'll continue on with these ratio and proportion questions. All right? Good luck.